I'm going to check this. Check continuity, make sure it's not shorted to ground. Before I take it off of here and check it out. Okay. This is high voltage in, this is low voltage out. Okay, I got contacts through it. Alright, it's not shorted to the case. Alright, I believe I got a good one. I'll need some jumpers. I'll need another meter. And a cup of coffee. And what else? Oh yeah, I guess gonna need 12 volts from a battery. This is the negative. This is the positive. It goes to the positive. Here. This is in. This would be the 12 plus volts. This was out, so this will be the 10 volts. And let's see if that works. Okay, we're still connected to the battery. Volts DC, that's amperage. DC's over here. Okay, here's 20 volts. The meter has to be grounded. I'll just clip you here. Okay, now I got 1279, 1288, because the charger is on that battery post, so the charger is dropping about 4 amps in there. So this should have 10. Huh. Why is it doing that? Because the contacts are heat sensitive. It heats up and breaks. That cools off, reconnects, so it's doing this. Almost like a flasher would work, okay. Okay, so let's get rid of this. Okay, it is warm. Since this has a rubber cover, I won't be accidentally shorting again. This goes to there, this goes to the 10 volt side. Also has a rubber cover, so that way it won't short out. Okay, now this goes to the meter, positive. Come on, it up here, don't be falling apart. $77 degrees. Get the, don't you hit that wrong one. It's 89 degrees. This is the power coming in. Almost 13. The charger is putting out the amperage. Terminals on the voltage stabilizer. The blade is the 12 volt plus in. The C channel type terminal is the 10 volt average. That's the voltage that's coming out. 97. Got another meter here. I got a test light, that's all. Let's see what the brightness is. 13 volts coming in. Let's see what the stabilizer voltage is doing. There's the circuit working, opening and closing. The temperature gauge and the gas tank fuel gauge react slowly to this voltage change. You won't see this needle jumping empty full, empty full. It's going to try to stay still. Okay, I've got another clamp here. Maybe if it's right here, you can watch the two heat up and cool off. It has to be grounded. Disconnected from the ground has another effect. If the voltage stabilizer loses ground, that's what we want to demonstrate here. So the voltage stabilizer is going to lose ground. Circuit is broken. Now the bimetal strip is not heating up. The electricity is just going straight through. It goes in and it's coming out at full power. So the gauges are going to be reacting differently because they're full powered and not at the 10 volt range. Maybe they have a ground on the voltage stabilizer running to a ground somewhere. Maybe they've moved it. If the wire gets loose, the gauges kind of go wacky. Then the wire reconnects to the ground. The bimetal strip should heat up, open, and break contact and go back to normal operation. So if the voltage stabilizer goes bad, what happens? What happens when the voltage stabilizer goes bad? It just loses the output? I don't know. This concludes my what if the voltage stabilizer loses ground question. And you've seen it here first on Spitfire Garage. Oops.